Hi there, this is Shaun, and this video is about dark field microscopy, which is another important technique in microscopic field. And this video is under the sequence of cell in focus. We are discussing different type of microscopic technique. So dark field microscopy is a very useful technique of microscopy where you can use your sample without staining. That's the uniqueness of dark field microscopy. So uniqueness of dark field microscopy is one thing, that you don't have to stain your sample. That is the main uniqueness of dark field microscopy. Now as the name suggests, dark field, so that's the name is because dark field, because that you have an image, you will get an image after the microscopic technique where the background is totally dark, and you will get your specimen. Like here you can see in the cover page that the totally dark background, and you are getting an image which is the totally very bright to investigate all the inner details of a cellular organelle. Okay, so that's the uniqueness of dark field microscopy. And actually what happens, sometimes the light which is coming from background, which actually noise, this noise actually means noise is actually going to be overloaded as compared to your signal from your cell. Okay, in that case you can get a better contrast, you can't get a better signal to noise ratio. For that purpose, dark field microscopy is actually a breakthrough technique. Okay, and we will see in this video the working principle, the image formations, and the advantage of dark field microscopy. Okay, so let's say you have a sample which you can't stain with a fluorophore. Okay, what is fluorophore? What is the fluorescence? How fluorescence is used in the light microscopy? If you don't have seen my video about that, just check it out first, then come to dark field, because you need the concept for fluorescence microscopy. What is fluorescence and how it's used in the light microscopy? So as you know, fluorophore is a organic material which you have to tag, which you have to conjugate with your organelle in order to visualize your organelle in your image for a light microscopy or for a bright field microscopy. But in contrary to the dark field microscopy, in dark field microscopy you don't have to stain. Understand? You don't have to stain any organelle. You can just directly take your cell specimen and take in the specimen plate, and you can just image it in a dark field microscope. You don't have to stain anything. That is the uniqueness. If you have the cell where when you are staining, maybe your functions of that particular organelle what you are desiring to know, that can change. So in that case you can't use the staining, and that case dark field microscopy will be a great technique in that type of microscopic imaging experiment. So now we have to understand what is the working principle of dark field microscopy and how the image formation happens. Okay, to start that, I just want to make an analogy of the image formations in dark field with this picture. So here you can see a beautiful girl's picture here, and here you can see the total background is very dark. Total background is dark, and you can see the face of the girl only. So our target is that only. We want to see the cell only. Any other background information we don't want. Extracellular matrix, what is the cell addition, what is the other tissue place. We don't want to see that. We want to see only cell and a particular organelle only. Okay. So if we want to see a particular cell, we can just use dark field microscopy where we just remove the background informations. Okay. So here you can see image of a girl where the as the dark background is there, that's why the whole face is very much bright, and you can get very inner details. You can get very small details, like you can see the nose, how the nose of the girl is, how the eye, a beautiful eye this girl has, so how the eye of that girl is, how his all the face cut, etc. So etc. Small details you can investigate by this picture, this type of picture where you can have a dark background. And that is the dark field microscopy, how it works. Now it will be curious to know how the image formations actually happening. What is the mechanisms of the image formations? Okay, so here I have shown optical pathway of the dark field microscopy, where you can see this is the This is the light source where light are coming, and these are set of the condenser lens. As you know, condenser lens is used to focus your light beam, and here is the specimen where you can see the image of this specimen. The white color is the specimen, and image of the specimen is here in this projection plate. And here is the objective lens. You know, objective lens is used before your eyepiece, and here instead of eyepiece using a plate, bottom of the microscopy, where the signal are going to be recorded. Now everything is equal to the bright field microscopy, only they have used some, we will see, they have used some special type of condenser lens. So their concept is that we want to remove the central region of the light. Here you can see the central region. There are light in the central and in the edge region also, but here some special type of condenser lens they are using. They are using a special type of opaque disc where you have a concentric circle. Inner circle is there, and you have a gap, circular gap, and then another circle. So whenever you are putting that that opaque disc in your pathway of light, then only the edge light, only the light from the edge will come out after that lens, after that condenser lens. So no central light will be come out. As you can here see, as you see here, that no central light will come out. Only the edge light will coming out. Okay. Central light is blocked by a disc, which blocks the central light. Okay. So actually what happens, central light actually doesn't give any spatial informations, which is undiffracted light. When we will get the light from the specimen, which is directly go throughout the specimen in light microscopy, which is undiffracted light, means if we allow, what will happen if we allow the central light? This will happen that if we allow the central light, it will go throughout the condenser lens and it will fall on the specimen, and coming through the specimen means it will not diffracted. It will not diffracted through the specimen. And whenever any light is not diffracted throughout the specimen, then it will not contain any information. It will not contain any spatial information as well as temporal information for the specimen. So why we will bother about that light? That's the main concept. Why we will bother about that light? So they thought we want to just remove that light which doesn't contain any spatial information, any temporal informations, and that is the central light. If we block the central light, we will get only the diffracted light from the specimen, and the diffracted light contains whole bunch of information for your specimen. And that is done by using a condenser lens, special type of condenser lens. Here you can see the light path. The only central portions of the light beam is blocked, and thus you can get only the diffracted light by the specimen here in the recording plate, and this it will hold bunch of only your specimen information, no background information, no noise. That's the main uniqueness. Now we will see what is the difference of bright field microscopy. And so right hand side is the bright field microscopy and dark field microscopy is the left hand side. Here you can see, and the main difference, if we focus in the part of objective lens, specimen and condenser lens, this part will show the main difference. So after objective lens and then eyepiece, everything is totally equal in both the case, dark field and bright field. But the main problem happens, main change, main engineering happened in the condenser lens. So in condenser lens, you can see here, for bright field microscopy, or let's say you can say white field light microscopy, the whole beam of light are going. The whole beam of light are going coming on the lens, and they are being converted. They are being converted to a very well-mannered focus beam and coming on the specimen, and their emitted light are being recorded. But in this case, the central portions, which doesn't contain any special information, any specimen information, that is going to be blocked. Here you can see the disc, the central portions of the disc is totally black. That's why it will block all the light from the central portions. That is the main difference of bright field microscopy and the dark field microscopy. Now here you can see in a better way what is happening. So here is the light source and here is the collector. Here in a central aperture they are using. Aperture can be two types. So you can, by using aperture, you can block the diffracted light, you can block the undiffracted light. Here they are using a light aperture which can block the central light, called central aperture, which will block the undiffracted light, which will not contain any informations. That's why you are getting better specimen details in your image. So special type of condenser that contain an opaque disc which blocks the light, that would enter the lens directly. this blocks all the light that will enter the lens directly. So this light is going to be blocked, and another light are coming and falls on the specimen. Then another engineering are there. Another engineering is used by objective aperture, and this is a normal thing that they want to block the other lights which is going to be directly from the normal light source. So this yellow color dot lines is actually the direct light which is coming from the light source. This doesn't contains also no information. This doesn't contain also any information. So this we don't need. We only need the light which is diffracted, which is making interactions with your specimen. That will be called diffracted light. That's why they are also using objective aperture, and by this they are blocking the direct light which is coming from the coming from the light source, and only the light they are taking into account which is called the diffracted light by the specimen. Okay. And here you can see after the objective aperture, it will be being recorded on the dark field image recorder, which is going to be generate a dark field image. So the light diffracted by the specimen only are going to be recorded. So two things are happening, two steps engineering has happened here. One is the condenser lens, which is a special type of condenser lens which blocks the light in the central portions. That will be called central aperture. And why you were blocking the central portion? Because in the image plane, when we will get the light from the central portion, and what we call undiffracted light, that will not contain any informations. But the light which is actually diffracted, that will contain the every information, spatially as well as temporally for your specimen. That's why in the another portions of engineering, in the last part, that is objective aperture, by using that we are only taking into account the light diffracted by the specimen, not any light which is coming directly from the light source. That's the main engineering has happened in the dark field. Now one image of dark field, particularly you can see this type of image where all the background are dark, but here you can see the cells are very light is shiny light, and that's why you can get any small details of your specimen. Okay, and that's why you will get a small details. And now in a minute we will see a very small video which will helpful to understand whole concept very intricate details. So here is the platform where signal are going to be recorded, and here is the lenses. This is the objective lens below, and this is the special type of condenser lens, and this is the recorded plate where the sample image will be recorded. This is the condenser lens. Follow. The central portion are going to be blocked. Central portions is going to be blocked by this condenser lens. Okay. And this phase ring stop the central part. Now the specimen is coming. This white color is the specimen. Now image formation will happen. This is the objective aperture. Okay. Now image formation will happen here. Image of the sample appears on the screen. This is the whole image. That's another video of phase contrast microscopy. We will see some another video. So hope we will understand all the concept for dark field microscopy. If you have any doubt, you just make a comment in the comment box, and I have made my mail in the description box. You can go there. Thank you for watching. Bye bye.